Hello everyone, welcome to my class. Today we shall talk about earthquakes. इससे पहले I have already covered the interior of the earth. However, today we shall talk about this chapter because it's extremely important. और इस chapter में जो important चीज़ें हैं मैं cover करते हुए चलूँगी. So do not worry about your coverage. Let's talk about this question first. Which of the following acts as a direct source of information about the earth's interior? There is a total segment in NCERT geography which talks about this. So volcanic eruptions, study of seismic waves, spatial variation in Earth's gravity or deep earth mining. You have to select the correct answer using the codes given below. 2 and 3 only, 1 and 3 only, 1 and 4 only, or 1, 3 and 4. Now if you have answered it correctly, then very good, but if you have not, let me just stress about the importance of this chapter. See, this chapter is extremely important. Specifically from NCERT we do find some references of this chapter in our questions as well. So let's first of all understand what are direct and indirect sources. Direct sources about the information of the earth are those sources like we interact directly with the surface of the earth. For example, mining. Here we are directly interacting with the surface of the earth. For example, volcanic activity. Again, what happens that all the interior parts of the earth, especially lava, gas, pyroclast, water vapor, everything comes out during volcanic activity. So we do understand through volcanic activity how the earth is made up. Earth is made up of lava in the asthenosphere, which I have already covered. Do watch that. I have provided the link over here. Gases are also there, pyroclasts are also there, you have minerals as well. So we do understand about the interior of the earth through volcanism, and this is a direct source because directly we are getting the evidence. So yes, volcanic eruption is going to be one of the direct sources of the information of the earth. Study of seismic waves. Here it means earthquake. Earthquake waves actually travel differently in the different layers of the earth. So we can understand that there is not a singular makeup of the interior of the earth, and hence we are able to understand it from a perspective of that the seismic waves travel differently. That means all the layers may have different density, different type of elements. So it's an indirect information, not direct. We are just doing approximation, we are just doing Aaklan, nothing else. Spatial variation in Earth's gravity, yes, it is also an indirect. Again, this is something that we just approximate, going by how the interior works, how the inner core, outer core rotates, then we can understand the Earth's gravity variation. Deep earth mining. If we talk about deep earth mining, we are directly interacting with the surface of the earth. That means it's a direct source. We know that there are two actual very deep mines in our earth's crust. One is Tautona and other one is Mponeng. Both these mines are where? In South Africa. They are so deep, just as deep as 3 to 4 kilometers. However, we find them so deep because as we reach downwards, temperature starts increasing. Temperature also goes up, pressure also goes up. Now when these two goes up, what happens that we will be able to see that as we move downwards, more and more temperature will go up. That means by the time we reach the core, it could go as far as 6000 degrees Celsius. So this is an indirect approximation. So once we talk about volcanic eruption, yes. Study of seismic activities, no. Spatial variation in Earth's gravity, no. But yes, deep earth mining is a direct source of information. However, the temperature and the pressure increase that is related to it is indirect source. But deep earth mining and volcanic eruptions do stand the test of time. So yes, 1 and 4 is going to be the correct answer. This one is the correct answer. Those of you who have answered it correctly, very good. Those who have not, don't worry, I will help you. With reference to the earthquake waves, consider the following statements. P waves are body waves while S waves are surface waves. The surface waves are more destructive than the body waves. Now we have to understand the correct answer. We have to choose the correct answer from the given below options. If we talk about waves, seismic waves are actually divided into two categories. One is of course body waves. Body waves are known so because they travel throughout the body of the earth. So we have P waves, which are primary waves. We will dwell into it. And the next one is S waves. So P waves are P waves and S waves are S waves. That means they both are body waves. The next one is surface waves. Surface waves also are of two category. Okay, one is the love waves. We will talk about that. And second one is the Rayleigh waves. We will talk about this as well. But just understand that P waves and S waves both are body waves. They both travel throughout the interior of the earth. So first is correct. till here, but after that it's incorrect, so this one is not going to be the correct one. The surface waves are more destructive than the body waves. Surface waves are, yes, they are, love waves and Rayleigh waves, they are much more destructive than the body waves. So this is correct. So first is incorrect, second is correct. Correct answer will be 2 only. Woohoo for those who have answered it correctly. No worries for those who have answered it incorrectly. Now the third question for today is, with reference to earthquakes, consider the following statement. A seismic gap is a section of a fault that produced earthquakes in the past, but it is dormant state presently. Benioff zone is a seismically active underground area within a subduction zone. Now we have to see which of the statements given above is or are correct. If you know what is a seismic gap, then you will be able to understand this question, answer this question very well. Seismic gap is actually one plate which is not showing any sources of seismicity or any earthquake origin, and the next one which is adjacent to it is showing it. So here we see that this particular piece of fault is not showing any sort of seismicity, so this comes as a seismic gap to us. Information will not be sourced from here. So yes, it's correct. Second, it is dormant right now. Yes, it may get activated in the future, but right now it is dormant. Benioff zone is a seismically active underground area within a subduction zone. Yes, what is a subduction zone? A subduction zone is a zone which is created due to the subduction or undergoing of one heavier plate under the lighter plate. When it goes under the other lighter plate, there is a zone which is created underground, which is known as the Wadati-Benioff zone. Wadati-Benioff zone. That means it is a seismically active area. Now here volcanism and seismicity both can occur. So yes, Benioff zone is a seismically active underground area within a subduction zone. Yes, this is correct. We will dwell into this as well. So first is correct, second is correct, both 1 and 2 will be the correct answer. These kind of questions do come. Now first let's talk about what is an earthquake. I'm not going to waste your time, so we are going to just jump into it. Although we have so much to see, I will go through each and every one of them. So first of all, we are talking about what is an earthquake. Looks very simple, but it is not. When we are going to understand it, it will become a little complicated. However, I am going to simplify it for you. But just talking about the background, earthquake for the first time was connected through land movements according to some person. This person is Robert Hooke. Yes, he is the same person who discovered cell. Multi-talented people back then, an Englishman. He said that earthquake is connected to land movement. So he was the one to say it, and this was as early as 1705, beg your pardon, 1705. Thereafter, it looks like 19, no it's not, it's 1705. Thereafter, in 1755, a tsunami emerged in Portugal, and it killed approximately 70,000 people. When a tsunami of this large expanse occurred, there were needs that we need to study about the earthquakes, how are tsunamis caused. In 1850, Robert Mallet, he discovered about seismic waves, that earthquakes do create seismic waves. Alright, and thereafter, not too later as we can know, in 1897, it was Richard Oldham who said that there are actually P waves and S waves. Later on, as time went by, we started to understand about other waves as well. But this was the preliminary study which was done from the perspective of earthquake. So this is all preliminary, beg your pardon, preliminary study. Now, as we moved forward in 1912, we all know what happened, the continental drift theory by Alfred Wegener, A. Wegener. Thereafter, we had the theory of convection currents. All this will be taught later on. Theory of convection currents by Arthur Holmes. We also had in 1960s theory of sea floor spreading. Theory of sea floor spread. and this was done by Harry Hess. Alright, and thereafter finally in 1967 we had from Morgan, Parker and Chase, not Park, I said Morgan, Parker and Chase, can you imagine guys, McKinsey, the theory of plate tectonics. The theory of plate tectonics. So this is how after many years we thought that we had it. No, every day new theories are coming, but this is the actual study that has been done. So this we can say modern theories or modern studies related to seismic activities. Alright, so we will talk about earthquakes now. However, I had to set the background, how the background had to be set. You see, this will be available on my Telegram channel, so make sure that you subscribe to my channel. Now, what is an earthquake? We can say an earthquake is the vibration of the earth. Okay, the waves produced are called seismic waves, which are highly destructive, Alright, now let's move forward and talk about these many things. So if I had to put earthquake, what is an earthquake? Let me just walk you through here. How does an earthquake occur actually? No, this is not a square, I wanted a square. For example, this is the internal region of the earth. This is the crust, okay, and here is a fault line. A fault line is a region, basically this is a fault line. A fault line is a region where two plates may be interacting with each other, and I have drawn it smooth. However, the fault lines are never smooth. They are actually very crooked in nature, like this, and hence when they go either like this towards each other like a transform plate boundary or away from each other, they can get stuck with each other, and the place where they are stuck, for example here they are stuck, they will need a lot of energy to release themselves. So energy keeps on getting accumulated, and when enough energy is accumulated, the plates, they move past each other and lots of energy is released. This energy is propagated in the form of waves. So energy is released at this point, right? Wherever the energy is released, it is known as focus or hypocenter. This is the place where the energy is released. Energy for what? Energy for the plates to free themselves. And as the energy gets released, just above it, where the first wave emerges and affects that place, is known as the epicenter. You must have heard about it so many times. Epicenter yahan hai, epicenter is here, epicenter is there. So this is the story of how earthquake occurs generally. Okay. However, we do have division or the types of earthquakes as well on the basis of depth. Where the earthquakes occur, that also matters. For example, if an earthquake occurs up to 60 kilometers from the surface of the earth, this will be a shallow earthquake. And because they are occurring very near to the surface of the earth, they are highly destructive, a highly destructive region, simply because they are very near to the surface, simply because of that. The next one, from 60 kilometers up to 300 kilometers, is the intermediate earthquake. The intermediate earthquake can be dangerous, however not as dangerous as shallow earthquake. And the next one, from 300 kilometers up to 700 kilometers, is the deep earthquake, deep seated earthquake. This is the least destructive of all. Why? Because this is coming from the very lower levels of the crust and even mantle. It can reach up to mantle as well. Least destructive. And because whenever the seismic waves are created from over here, they get weakened as they reach the surface of the earth. Weakened waves. That is why not destructive. Okay, so they just die down deep inside the crust, so not an issue. So the types of earthquakes are actually 3 types of earthquake based on depth. Keep this in mind, based on depth. Now let's move forward, and what should be the next topic of discussion under this types of earthquake we have discussed? Yes, of course, we have to talk about seismic waves, but before that we should talk about the causes of earthquakes. What could be the causes of earthquakes? Many. If we talk about man-made causes, human-made causes, I should be inclusive. Now, human-made: deep drilling, intensified drilling, reservoir-induced earthquakes, dynamite explosion. These generally are human-made. Okay. Then if we talk about the causes which are natural: volcanic activity. Natural, we have volcanic activity, we have landslide. Okay, we can have meteorite strike as well. However, as of yet we have not experienced it. And convergent boundaries, how can we forget that? Convergent, divergent or transform boundaries all do cause earthquake. But convergent boundary, I have to pick it up because we just studied about the David-Benioff zone. Convergent plate boundary is a boundary where a heavier plate is undergoing another lighter plate. This is the lighter plate. And when it is subducting, it is causing seismicity. So this is subduction zone. Just beneath the subduction zone, approximately over here, we will find the Wadati-Benioff zone. Wadati-Benioff zone. This is the zone of seismicity. So convergent plate boundaries can also do it. However, we see that in all plate boundaries, be it convergent, be it divergent, or be it transform boundaries, all boundaries show seismicity. Not a problem with that. But I had to pick this one because we just went through a question. Now if we talk about seismic waves, which is of course very important for us, let's talk about seismic waves first. So yes guys, how many types of seismic waves are there? We all know that there are 2 types of seismic waves. One is the body waves. Okay. Another one is the surface waves. By the name only you can understand what are body waves and surface waves. Body waves are actually 2. First is primary wave. Second is of course by the name itself secondary waves. Then we have surface waves, 2 types: love waves and Rayleigh waves. Alright. So first let's talk about body waves. What are body waves? Body waves are the waves which travel throughout the body of the earth. And as they travel throughout the body of the earth, they will keep on creating energy transfer, and they do help us. This is an indirect source of information about the interior of the earth. Why? Because the way waves travel, they tell us if the velocity of waves is anyhow changing somewhere, we will be able to understand that the earth is made differently over there. Surface waves, these are the waves which are created when body waves interact with the surface. Body waves interact with the rocks on the surface. Rocks on the surface, and they are actually the most destructive, both surface waves, more than body waves. Now if we talk about body waves, let's understand how body waves actually work, because this is also important. Why should we give S waves less importance, right? So first we are going to talk about primary waves or P waves. Primary waves and secondary waves. Primary waves are primary because they are the first to reach the seismograph. Seismograph is an instrument to measure seismicity. Then they are actually able to travel in solids, liquids and gas as well. Nice. They are actually 1.7 times faster than compared to S waves. They are the first one to come on the seismograph, that means they are warning waves. And they travel in the direction, in the way sound waves travel. Who can tell me sound waves travel in what way? Yes, please do tell me, anybody in the comment section. So like this, the sound waves travel like this. This is the traveling way. So if we talk about P waves, they travel just like sound waves, in which the propagation of waves try to match the displacement of the particle. Okay. Who will tell me in the comment section what these kind of waves are called? Okay. So this is primary waves. Secondary waves are secondary because they are the second to reach the seismograph. Now keep in mind that P waves are just 7 times faster than S waves because they can travel in solid, liquids and gases. Also they serve as warning waves and they are least destructive. They do not destroy much. Okay. But here secondary waves, they can be more destructive even if they are second to reach to the seismograph, because they can travel only in solids. They cannot travel in another medium, only in solids. And hence, because of the shadow wave which is created by S waves, we will talk about shadow waves as well. We will be able to understand why, why there is a shadow zone which is created by secondary waves, and why do we get it as an information about the interior of the earth. Now, as you see, this is the direction and this is the way in which S waves travel, like light waves. And the displacement of the particle is like this, up and down, up and down. Who will tell me in the comment section what is it called? If anybody is able to tell me, please do tell me. Okay. So these two are actually body waves, which was discovered by Robert Mallet in the year when? I have written over here, are you not responding? Hello, excuse me. Here Robert Mallet, I have written Ballet, I am sorry. Seismic waves he has discovered in the year 1850. Alright, so he said it. Thereafter, 1897, it was Richard Oldham. He said that P waves and S waves are created. So keep this in mind as well. Robert Mallet and Richard Oldham. Body waves are seismic waves. Robert Mallet, he discovered the seismic waves. And Richard Oldham in 1897, he discovered P waves and S waves. This is available. Please do understand, you can get this from a Telegram channel. Now, let's talk about other waves which are actually surface waves. Surface waves are surface waves because they travel only through the surface, and they are love waves and Rayleigh waves. As we compare both of them, Rayleigh waves does up and down displacement as well, side to side shaking as well. So that is why they are the most destructive. Your homework will be to tell me what are love waves actually created, how do they work. But just keep in mind, both are destructive, but Rayleigh waves are most destructive because up and down and side to side, both movements are done. by Rayleigh waves. That is why this is the most destructive. I am writing it time and again because you have to remember it. Now let's move on and talk about how we do measure the earthquake. Measuring of the earthquake. The earthquake is actually measured through scales and seismograph as well. However, we are talking about scales, the scalar version. There are two scales. One is Richter scale and another one is Mercalli scale. The Richter scale actually measures the intensity, beg your pardon, it measures the energy released, that is the magnitude of the earthquake. This is the magnitude of the earthquake, which is measured between 0 to 10. Whenever you are going to study that 7 Richter's earthquake has come, always remember it is the Richter scale, because we see what amount of energy has been released. However, the Mercalli scale is actually related to intensity and how much destruction has been created. How much destruction. This all is related to what amount of population lives there. So this is based on observation rather than measurement. Observation. This is much to do with measurement. Alright, keep this in mind. So this is how we measure the earthquake. Keep this in mind, it could come in your examination. Alright, so we did so many things. Let's just look at what is left of us. Shadow zone. How can we forget shadow zone? Shadow zone is very important, guys. Let's talk about the shadow zone because it could come in your paper as well. Here we do discuss shadow zone. I'm just going to discuss it over here. Shadow zone, if we ask ourselves what is a shadow zone? Shadow zone is actually a place where there is a lack of record of seismic waves. Alright, so let's try to understand with these two graphs, these two diagrams. Here is the core. Here is the core. Again, core. Now, for example, here is the focus. The waves start traveling. These are body waves, of course, in such a manner that it is moving throughout the interior of the earth. Throughout the interior of the earth, it is moving and moving and moving. We have P waves reaching till the angle of 105 from the focus, 105 degree, 105 degree. We have S waves as well. For example, this one is S waves, the lighter one, the light orange one which I have drawn. These are the S waves, which are also traveling along the P waves. These also occur up to 105 degree. Now what happens that the P waves remain absent between 105 to 145 degree till here. However, they do occur after this zone. For some reason, this is only the area where the P waves are occurring, but S waves still remain absent. So this zone where P waves do not occur is actually a shadow zone, and S waves are also not occurring here. Still, this is the shadow zone for P wave, because P waves will occur after 145. So between 105 to 145 P waves are not occurring. Now S waves, as you have seen, is only occurring till 145. So S waves do have a larger shadow zone as compared to the P waves, because S waves are only and only available till 105 degree. After that, the entire zone is not registering S waves. So this is a S wave shadow zone. Now, why is it happening? It is possible for S waves to travel only through solids. That is why other regions it is not reaching, it is getting reflected or not being propagated by liquids and solids, other solids thereafter. P waves on the other hand, they can travel in all the mediums, still they are getting refracted. So this is all a reason of refraction, because of the result of refraction, that the P waves are getting their mode transferred, and when they are changing their mode, they are getting refracted just like the light does. So we can say that the shadow zone of the S waves is larger than P waves. Keep this in mind. All right. Now let's move forward and talk about our next topic, which is, let me see guys. It is, yes, shadow zone, earthquake zones of India and the challenges. Now if we talk about the earthquake zones of India, which is over here guys, earthquake zones of India, actually the earthquake zones are divided into 4 categories, from zone 2 to zone 5. So zone 2, zone 3, zone 4 and zone 5. So 1, 2, 3, 4. There are actually 4 earthquake zones, and these 4 earthquake zones are as such. Zone 5 is the most destructive. Zone 4 is destructive, quite a lot still. Zone 3 is moderate, and zone 2 is low risk zone. Who does this? It is done by Bureau of Indian Standards. So keep this in mind. Bureau of Indian Standards does it. Most of the Himalayan region, this and almost the entire northeast India, it lies in zone 5, because this zone is a zone of subduction, between the Indian plate and the Eurasian plate. That is why this is a zone of subduction between the Indian plate and the Eurasian plate. So most of the Himalayan region is either in zone 5 or in zone 4, but the entire northeast India, majority 95% lies in the zone 5th, the most destructive one. After that, here also this region also lies in zone 5. The coastal region mostly is falling in zone 4 region, again zone 4. This is zone 3, and most, not all, but most of the central India lies in zone 2. Okay, so just keep in mind that most of the Himalayan region lies in the most seismic, active seismic zone because of the Indian plate and the Eurasian plate, and this also lies in the Himalayan alpine belt. We will discuss this as well, Himalayan alpine belt. So that is why this is the most seismically active area. Keep this in mind. What are the challenges with predicting earthquake? Biggest challenge is we do not have any reliable criteria for measuring earthquake. We have lots of gaps in our researches. We cannot predict it with precision. Early warning system is not enough, because only one gas, radon, gets emitted if there is any changes in plate tectonics. So that is also another problem. Alright, and because they occur deep within the crust, it's hard for us to understand how do we put our seismographs over there. So these are the many things that we had to understand from the perspective of our examination. If you have any question, feel free to drop them in my comment section, and I hope you found this chapter very interesting. Thank you so much everyone. Take care and bye bye.